So this video is going to go over the main two kinds of calculations that you'll do with uncertainties in order to carry them through any sort of calculation result you're doing with lab results or with numbers given to you on the IB exam. So the first thing is when you are taking two values and you're adding or subtracting them together, and both of those measurements, assuming we're using measurements, have some sort of uncertainty along with them, then you actually have to add the uncertainties together. The idea being that if you're uncertain about one mass and then you're uncertain about another mass, if you do a calculation involving both masses, afterwards the uncertainty is actually greater because you have to combine the uncertainties of both measurements. The nice thing about adding and subtracting is that the values must have the same unit if you can actually add them together. So if you're adding one mass with another mass, then they should both be in grams. And so you can just add the uncertainties together and the unit should still be grams. Obviously, you can't subtract a gram from a milliliter, and so you won't run into issues of subtracting or adding things that don't have the same units. So adding and subtracting values is really simple for adding up uncertainties. The key just being to remember that even when you're subtracting two values, like if you're using a balance and you put a weigh boat down first and you record the mass of the weigh boat and then you add something to it. And so after you take the masses, you're going to subtract out the mass of the weigh boat. The idea is that you still add the two uncertainties together. So the more measurements you use, you have to add up all the uncertainties from the different measurements. The only other thing there is to the adding and subtracting rule is to make sure you double check on your rounding. So when you're done and you've combined uncertainties, make sure you just have one digit of uncertainty and that the uncertainty, its precision or its number of decimal places is the same as the number of decimal places in the now combined measurement. So here's an example. If we had two volumes of water recorded with these graduated cylinders, the first one seems to be right at the 24 line. The smallest increment is 0.1, and therefore the uncertainty the smallest increment is 1. I apologize. The smallest increment is just 1 ml, and therefore half of that is the uncertainty. So plus or minus 0.5 cm cubed. So this is how we would report the volume in the first container. Second container has the same uncertainty. The volume seems to be between the 44 and the 45, and so we would probably estimate it at 44.5 plus or minus 0.5 cm cubed. So if I was going to add these two things together, obviously the adding part's pretty simple. I get 68.5 cm cubed as the combined volume. Okay, however, now I'm going to add the uncertainties together. They're both uncertain by half a milliliter or half a cm cubed. So when I combine those, I get plus or minus 1 cm cubed of uncertainty. Now I'm going to check the uncertainty. Is it rounded to one digit? It is. It only is just 1. It's in the ones place. It's not 0.11 or 0.15, something like that. So I already have one digit of uncertainty, so that step was already done for me. And now I need to make sure that the actual sum, the combination of the two volumes, is to the same decimal place as the uncertainty. So the uncertainty is in the ones place. And as it stands, this measurement actually this sum goes beyond the ones place, which actually doesn't make any sense because my combined uncertainty tells me I'm actually not quite sure of the volume in the ones place. So I should not report my measurement, my combined volume, to anything past the ones place because I'm actually uncertain about the ones place itself. So what I do is I take these two and I have to round off that 0.5. 0.5 rounds up, and so I end up with 69 cubic centimeters plus or minus 1 cm cubed. This means that the combined volume could be anywhere between 68 centimeters cubed and 70 centimeters cubed of volume, and so this is the best way to report it. The second type that you do is unfortunately a lot more complicated. It's when we end up doing calculations where we are multiplying and dividing measurements that we've taken that have uncertainties. The problem really is that when we multiply and divide things, we change units, and therefore we can't just add the uncertainties together because I can't add a gram to a centimeter cubed, and I can't add that to a degree Celsius. It just doesn't make any sense. So the way we get around that, we still just want to really add the uncertainties together. The way we're going to get around that is first you have to get rid of the units on the uncertainties by converting them into percentages, and I'll show you how to do that below. So you essentially just divide the uncertainty by the measurement itself. And so instead of saying that you have 10 grams plus or minus, here we go, plus or minus 1 gram, this is the same. 1 is 10% of 10. And so this is the same. Instead of saying plus or minus 1 gram, we could also say it's 10 grams plus or minus 10%. And really, those two things mean the same thing. I've got a mass of 10 grams, but I'm uncertain of about by 1 gram on it, or I'm uncertain in 10% of that measurement. So I convert what's called an absolute uncertainty, where it has a unit, into a percentage uncertainty. Once I've done that for all the different measurements in my calculation, I can then just add all the percentages together, because now once they're percents, they all don't have a unit. I can put them together. And finally, once I'm at the final value, I will turn it back into an absolute uncertainty, and I'll follow those same rounding rules. So here's an example that's worked out. If you have an object with this mass, 2 grams, plus or minus 0.1 grams, and a volume of 4 cm cubed plus or minus 0.5 cm cubed, calculate the density. Density is mass divided by volume. So to get the density, I just do 2 divided by 4, 0.5 grams per cm cubed, gram per cubic centimeter. Now you can see that the units are different. Now, when I've divided, the units actually combine together. So I can't just add 0.1 grams and 0.5 cm cubed. That won't make any sense. So what I've got to do is convert each of them into a percentage. I do that by taking the uncertainty itself, 0.1 grams, divided by the measurement, which in this case was 2 grams. I times by 100 to make it a percent. So 0.1 out of 2 is actually 5%. So that's the same as saying I have plus or minus 5% uncertainty on my mass. I repeat that process for the volume, and that actually ends up equaling plus or minus 12.5% on the volume. So that's step number 1, turn the uncertainties into percentages. Second step, add all the percentage uncertainties together. In this case, there's just 2, 5, and 12.5. And so that combines so that in total, I have 17.5% of uncertainty. The third step is turn it back into an absolute uncertainty, something that has a unit. The way you do that is take the uncertainty, write it as a decimal, which means you have to divide it by 100. So this is 17.5% written in decimal form, and times that by the final answer, that density that we figured out at the beginning. So what is 17.5% of this density? Well, it's plus or minus 0.0875 grams per cm cubed. This is our final uncertainty, but it hasn't been rounded off properly. So we've got to get rid of all these extra decimal places, because we can only have one digit of uncertainty. So I round it off, I get plus or minus 0.09. So that's actually going to be how I report my final uncertainty. And then I've got to make my density match. And so my uncertainty is saying that I'm uncertain in the hundredths place. So I'm actually, in this case, I'm going to add a 0 to make sure that I have the same number of decimal places in my measurement as I do in my uncertainty. So in both cases, I've got 2 decimal places. So it is a bit of a pain. There are a lot of steps to it, but you're expected to know it for IB exam questions, and you're definitely expected to show that you can do that when you do your IA and you show your uncertainty processing.